Hello, my name is Benjamin Wynn, and I'm going to be doing Physics Lab 4. So we're going to start it off with the purpose and beginnings, where the purpose is to observe the relationships between spring energy, gravitational energy, and kinetic energy on a pendulum. The principles will mainly be the energy principle, and it will be shown in simulation in the graphs from it. The system includes Earth's gravity, the spring, and the object. So the equation in principles includes the pendulum period, the kinetic energy, the spring potential energy, the gravitational potential energy, the work energy theorem, and the law of conservation of energy. These all will be calculated within the code. So we have tracker data, which is essentially the video that we were given, and as you can see, we calculated the mass at the point, and using the tracking, you can see how it is creating an oscillation. So, if we calculate that in a code, you can see that we start off with the spring constants up here, which we got, and the relaxed length of the spring, which we also got. In order to calculate the actual length, then you're going to do the bulb position, aka the mass, and the origin, and you're calculating the S using the magnitude and the relaxed. Using this, you can calculate the gravitational potential energy, where the other ones you can use the positions and the ball's velocity to calculate the kinetic and the gravitational. So within the calculation loop, you're going to be calculating the force of gravity, the force of spring, and also just the uh, total kinetic energy and all the energies. These will be changed between uh, what you have currently as well as the delta, because you are calculating that and demonstrating that for plotting in the graphs. So, as you can see, you have the graph on the top right, which represents all of the different uh, changing energies, whereas on the left and the bottom right, you have the x position and the y position, because it essentially represents how accurate it is to the actual experiment versus the model. So here's the model, and I'm just gonna let it run. And as you can see that it is a little off, but it's just because of how uh, like situational the points are. So the model roughly represents the actual position and is creating the curve that represents the entire oscillation. I can skip to the end, so it demonstrates the Lewis curve. Anyways, so the main thing of what does it mean? So it means that the principle of energy is conserved because the value of the energy is never increasing or decreasing, but it represents how the values are essentially distributed between each other. Now, you can look at the graph, but you can see how it's all waves. They're all representing the change in energy. Delta E stays at 0, so essentially it is not changing. The average oscillation period of the difference between x and y is represented in the period of 1.63 for x and 1.52 seconds for y. And you might notice that there is a difference, and that's mainly because since the angle is higher than 15 degrees, it's going to cause t is equal to 2 pi, which is this is essentially just the oscillation period for a pendulum, to have the x period be longer than the y period. This is just mainly because the calculation of where the actual uh, string length is at is actually going to be longer when it's on the higher than 15 degrees. So, the problems. The main problem would be the human error of either clicking the specific middle of the object in tracker versus something like a little off, which causes x and y to be off, or slightly pushing it in the dropping of the object within the video. Now, that may not be like a huge thing, but it can cause slight problems. Personally, the main problem I have with this is the lacking calculation for drag or air resistance for the pendulum. You can see it in the previous thing, where it has the y position and x position, and you can see that it is slightly off. It gets slightly more off, roughly, as it goes further in the experiment, but that is pure speculation, and we would need more tests to actually confirm it. But those are the main problems, and I thank you for being here.